talk about this Arctic blast here. So if you're seeing graphics like this online, Arctic blast, dangerous cold, let me just tell you, if you're seeing these floating around on YouTube or on Facebook from Joe Schmo's weather page or acclaimed meteorologist, weather enthusiasts, and even some actual people who went to school for meteorology, are just doing this to hype up the event. They're doing this for likes and for views and clickbait because it's not really an Arctic blast. And we'll talk about this here later in the video. So please stay tuned for that, because here at Dynamic Weather Agency, we don't hype up these events. We don't use crazy lingo unless it's necessary. For example, as we move into winter, you're going to hear everyone start saying bomb cyclone and polar vortex. But when we use bomb cyclone, we're actually talking about the technical term is explosive cyclogenesis, which is basically just meaning that a low pressure is going to undergo rapid development over a short period of time. It's going to drop its pressure by so many millibars over a certain time period. And the other day when we were live talking about the tornadoes in Missouri, across southeastern Missouri, we did use some what people would say would be, excessive words, particularly dangerous situation, tornado emergency. But when we are using those, we're taking National Weather Service verbiage. So when the National Weather Service and even places like the Weather Channel, who names winter storms, aren't using Arctic blast for this cold, it is not an Arctic blast. And I'll explain to that here in just a bit. Now, taking a look at our long range, so one of the first things I want to take you guys a look at is, again, taking a look at our sea surface temperatures across the Central Pacific. You see those cooler than average temperatures across the Central Pacific? What we have going on is we have a lot of upwelling of cold water across the western coast of South America. We have very strong trade winds transporting that water from east to west across the central Atlantic. You can even see some of the Kelvin waves here with this cool ocean waters. And then across the western Pacific, we have downwelling of those waters. And this is going to be important as we take a look at what a typical La Nina does for North America. Now, as we take a look at the Climate Prediction Center's November precipitation outlook, take a look at this. Above average precipitation for parts of the northwestern portions of the United States, drier conditions across the southern half of the United States, and some more wetter conditions across the Great Lakes and into the Northeast. Remember that. Now, taking a look at our November temperature outlook, take a look at this. Above average temperatures for the most part across the western portions of the United States, a little bit across the eastern, maybe more neutral, especially as you get into the Great Lakes region. Maybe some above average temperatures across the New England, but for the most part, just remember above average temperatures across the western portion and across the southern half of the United States and a little bit into the Northeast. Now, as we take a look at the typical La Nina pattern, take a look at this. We have ridging in the west, wetter conditions in the Pacific Northwest, drier and warmer conditions across the southern half of the United States, wetter conditions in the Great Lakes region, and then warmer conditions stretching up a little bit towards the northeast, and then cold air funneling in to the northern plains. And you can see that here, a little bit near average temperatures in the northern plains where that cold air is going to be moving on in. So this is the typical La Nina pattern, and this is what we're going to expect for winter. Wetter conditions across the Pacific Northwest, dry, warm across the south, wetter conditions for the Great Lakes, and cooler air for the Central Plains and Northern Plains. Now, as we take a look at what happened in October, for the most part for October, the eastern two-thirds of the United States saw well above average temperatures, especially across parts of the upper Mississippi Valley, the Great Lakes region, and even parts of the mid-Atlantic into the northeast. Well above average temperatures, while the western coast and the western portions of the United States, the western third, basically saw below average temperatures for the most part for the month of October. And here is the precipitation from September 30th to October 30th. And it was relatively wet across October, and you can see quite a few places with above average precipitation. Northern California, the Northwest, even into the Northern Plains, the Corn Belt, into the Illinois, Indiana, Ohio, into the Tennessee and Appalachian Mountains, and into the a little bit in portions of the Northeast, into parts of New York, Delaware, and stuff like that. So for the most part, this was actually a pretty active October, relatively wet, especially across Illinois and Indiana, where a couple places I believe are going to be breaking some records for like some of the wettest October for the most part for a couple of places. So this was definitely a interesting October. Now, what are we looking at for moving into the beginning of November? Well, completely opposite. Here's the GEFS on the left, and the European on the right. And this is for the next today through the next 5 days. And the eastern two-thirds of the United States, both models are predicting below average temperatures. And the European model has finally backed off, looking closer towards the GEFS. I believe this model was overdoing some of the below average temperatures a couple days ago. And I think more of that's mainly due to some of the more higher resolution nature of the European model compared to the GEFS. And the European model was indicating this troughing, digging in a little bit more than that. And for the most part, both of these models are indicating that the western coast is going to be above average. Now, as we take a look at our day 6 through 10, this is from the Climate Prediction Center. Ridging is going to develop, warmer air is going to return for the western half of the United States, while the eastern half, eastern two-thirds, are still going to see below average temperatures. Here's the GEFS model, again in pretty good agreement with that, above average temperatures for the western half, and for the eastern half of the United States, still going to see below average temperatures in day 5 through 10, and that's going to continue through day 10 through 15. Now, taking a look at our National Weather Service high temperature anomalies for the next 7 days, you can see how this system is going to progress across the United States. Taking a look at this loop again, let me restart this. There we go. You can see how that storm system is going to track. All that cold air is going to dive down, and then it's going to eventually kind of stay across that southeastern portion of the United States, where that prolonged more period of cooler temperatures is likely to be, like by that 10 to 15 day and that 5 to 10 day forecast by the GEFS. Now, why are we going to see this cold air? Well, one thing I want to show you guys is it's very important to take a look at our teleconnections within our atmosphere. And this is based off of oceans and global winds and stuff like that. That basically tells us how the atmosphere is going to work. Now, why are we going to have this cold air? It's important to take a look at some of our teleconnections. And the first one we're going to be taking a look is our Eastern Pacific Oscillation. And these all these teleconnections do is they cause changes in temperature, precipitation, and upper level wind patterns across the United States. And as we take a look at, we were in this positive phase. As we move into the beginning of November, we're going to move into this negative phase of our EPO, our Eastern Pacific Oscillation. And it won't be until about as we get into about the 5th, where we'll become more neutral and back into a sort of positive phase of this EPO. And I want to show you the typical pattern of what happens when we move into this negative EPO. So with a negative EPO, basically the biggest feature we're going to be looking at is for ridging over Alaska, or basically the west coast of the United States, with a trough moving across the eastern portions of North America into the plains and into the Great Lakes region. And this is going to produce mild temperatures across Alaska, the western portions of Canada, so basically British Columbia into the northeast, and the western portions of the interior plains of Canada, and more colder conditions for the lower 48. Another oscillation I want to have you guys take a look at here is that PNA, the Pacific North American Pattern Oscillation that we have going on here. And for the most part, this is going to become extremely positive as we move into November. And this is going to be indicative of a very strong ridge developing across the western coast of the United States. All right, so now taking a look at our GEFS, 500 hectopascal or millibars, whatever you want to say, geopotential height anomaly here. And this is from the ensemble from the GEFS. And first of all, explain this chart a little bit. So this is taking a look at 500 millibar heights. And where 500 millibars is going to differ in heights depending on where you're at, located on the Earth. And this is due to density of the atmosphere. Is going to change the thickness of the atmosphere based off of temperature. So if you're near the tropics, you have warm temperature. Air is going to rise freely over there, and thus you're going to have a thicker atmosphere. While over the poles is a lot cooler, the air is more dense, you're going to have a lot of sinking motion, so the atmosphere is thinner in nature. So that's why we're going to see differences in the height of where 500 millibars is, and it can tell us a lot about temperature and stuff like that. So basically from the tropics to the poles, the atmosphere is going to slope downward. Now, taking a look at this chart and actually analyzing it, so what we have going on across the Eastern Pacific is this deep trough axis, and this could bring some weather to the Pacific Northwest for the most part, with a short wave behind it, and that's our negative EPO, indicated by that troughing that we have back there. And then you can see our positive PNA. That's creating a strong ridge, and this is also creating an mega blocking pattern. This is actually going to help prevent some of the weather from that's happening across the Pacific Northwest from continuing to move eastward across the United States, because that trough and that short wave causing the lift for a lot of that precipitation and the showers and storms that develop over there to be forced to ride up and over this ridge. This ridge is a bump. It has to go up and over. It's like a mountain. You can't just drive through it really that easy. So with this, so taking again a look at that positive P&A, that's indicated by that strong ridge, that positive poleward extent of these height contours across the western portions of Canada and into the western portion of the interior plains from British Columbia into the northeastern territories, and that's going to bring above average temperatures. On the eastern side of that, so you have high pressure here, and the winds around that high pressure is going to turn anticyclonically. So it's going to funnel some cooler air down here where we have this troughing developing, bringing below average temperatures to the northern plains, the northern Mississippi Valley, the Great Lakes area, where we have this troughing developing. And again, this is what we were talking about with a negative EPO, positive P&A. You're going to have the trough here, ridge here. And then also to take a note at with this, we also have ridging across the Atlantic right here. And this is also going to help trap that air down there and continue to keep it down there for a prolonged period of time. That's why we were seeing that from our 0 to 5 day, our 5 to 10 day, and our 10 to 15 day across parts of the eastern 2/3 into the southeast of the portions of the lower 48. Now, again, going back to that Arctic air. Another thing to take a look at this cold air, this troughing through here, these low height contours are originating from, as we take a look at our loop here in a little bit, they're going to be originating from the interior prairies of Canada. And this is not attached by all means to any Arctic air up here. The second thing to take a look at, and the other reason why I'm going to call this not a Arctic air mass, is going to be taking a look right here. This is our 1,000 to 500 millibar thickness, and we have certain values that I want to talk about in here. Anything above about 560, 570 decameters is considered tropical air. Anything between that to about 540 decameters is considered modified polar air mass. Anything below 540 to about 510 decameters is considered a polar air mass, and anything under 510 is considered Arctic air. And these are some more empirical rules by meteorologists that we have. These are kind of what the values we look at. 540 is our rain snow line, so that's where we start considering it a polar air mass, while we call everything below that until about 570 decameters a modified polar air mass, so a CPK air mass, and then we have our tropical air mass south of 570. But it depends on who you ask too on where does Arctic air start. So like I said, 510 is kind of where I go. That's where kind of National Weather Service goes. That's kind of where some other schools and other things I've seen, articles, that's where they consider Arctic air begins. DoD is a little bit different. So like I said, I work for the DoD too. And I do weather for the Air Force and Army a little bit. And we considered it at 528 decameters. Now, on this chart, a couple of places are below 528 decameters. Now, if you really want to consider that Arctic air, by all means, whatever. It's up for debate. I don't really consider it Arctic air. I still consider it a really cool polar air mass. Like I said, this cold air and that troughing is developing in Canada. It's not connected to any Arctic air at all, by all means. So I don't really consider this an Arctic air mass at all. That's literally just for likes, views, and clicks on the videos, like I did on this one. I put that graphic on here, and you guys clicked it. And the only reason why the DoD has a little bit higher one is more probably because of the effects to aircraft as you move into those cooler temperatures with icing and things like that, which I'm not going to get into this video or any time. I'm not going to talk about what I do with my DoD or my military. Now, taking a look at those 500 millibar temperature anomalies as we go up throughout the next basically 10 days, all the way out to November 10th, you can see how that air is going to originate across the northern plains, transition its way into the southern plains, move its way across the eastern 2/3 of the United States, and kind of stay across the southeastern portions of the United States. And again, I want to show you here on the 4th of November, I think this is going to be the coldest day for the most part for most people. You can just see eastern 2/3 of the United States for the most part, below average temperatures, with many places up 10 degrees below average, with some even approaching to about 20 degrees below average. You can see that across Kansas into Texas, Oklahoma, parts of southwestern Missouri and Arkansas. You can see 15, 20 degrees below average temperatures here on the 4th. And then that warm condition still continuing across the western coast of the United States due to that strong ridge. Now, again, taking a look at your high temperatures for the next couple of days. Today, below average temperatures for pretty much eastern 2/3 of the United States. And that's going to continue into tomorrow. This is Monday. Here we are for Tuesday, Wednesday. And this Wednesday and Thursday are going to be one of the 2 coldest days for the most part, I believe, mostly Wednesday. Here we are for Thursday, Friday, most of that cold air moving into the southeastern portions of the United States. And here we are for Saturday. Now, taking a look at our low temperatures, here we are for tonight, tomorrow night, Tuesday, Wednesday, Thursday. Here we are for Friday and Saturday. For the rest of today, some isolated showers still across parts of Pennsylvania, stretching down across the Appalachian Mountain region. But for the most part, I believe this area is going to pretty much remain dry, but we will still see some isolated showers across there. Rain showers still continuing across parts of the Northeast, and then again, that we're watching that snow across the Colorado into Nebraska. As we continue throughout the day, that system, that low pressure system off the northeast, is going to continue to push off to the north and to the east. Some stray showers possible across Michigan, but like I said, for the most part today, we're going to be pretty dry. As we move into the overnight, you can see some snow showers beginning to really strengthen across parts of Wyoming into Nebraska. Again, we're expecting some snowfall across that area. Highest snowfall totals between 2 to 4 inches, possibly some isolated areas up to 5, but for the most part, 2 to 4 inches, a large swath of 1 to 3. And then as we take a look at the western coast, you're going to see some of this rain begin to push on in to that area. But for the most part, that's not going to really transition eastward as we go throughout time. Those showers, we're going to see some isolated showers on Tuesday across parts of Oklahoma, Missouri, into the Tennessee and Kentucky and Ohio River Valley. Some more showers and some snow developing across the western portions, across the Rockies, again, across Wyoming, Idaho, Montana, and into Utah and Colorado. On Tuesday evening, some showers across parts of Texas possible, and the mid-Atlantic, New England as we move through Tuesday. Wednesday, those showers are going to begin to move across portions of the central and southern plains, and then they'll eventually be moving on towards the southeastern portions of the United States. Again, that rain is still continuing across the western coast of the United States, and that rain is still not transitioning eastward. That's again due to that omega blocking pattern. All that stuff is going to be forced up to ride up and over that ridge. That hill is there, so it's not going to be able to transition eastward really easily. Thursday, showers across Mississippi River Valley into the Tennessee Valley, southern Ohio Valley, moving on towards the Carolinas and mid-Atlantic by the time we get into Friday. And then that low pressure system is going to start moving off to the north and east with more showers across basically the Ohio River Valley, mid-Atlantic, and into the northeast. And then as we get towards the end of this, as we go through Saturday, Sunday, and into Monday, we'll begin to start seeing some higher elevation snow across the Pacific Northwest, across the Cascades, and into the northern Rockies, especially as we get into Tuesday with this next push by that shortwave. Moving on through with that EPO that we have over there.